All right, guys, welcome to part 3 of my set of videos on constructions. Like I said in the previous parts, if you're looking for a specific construction, I have it time-stamped in the description below. Click timestamp, it will bring you to just the how-to on that. All right, guys, now we're up to those constructions that everyone hates. They're just annoying. So this video will go through creating an Orthocenter, a Centriod, a Circumcenter, and an Incenter. And then furthermore, on the Circumcenter and Incenter parts, you'll be able to circumscribe a circle on the triangle and inscribe a circle in the triangle. All right, so what a point of concurrence is the intersection of multiple lines. Specifically for what we're going over, points of concurrence are the intersection of the same types of lines in a triangle. All right, so this next construction we're going to go through is constructing an centroid. All right, I think that's the easiest out of any of them because there's less involved in it. A centroid is the point of concurrence, or the intersection point between the medians of a triangle. Now, what is a median? A median connects the vertex to the midpoint of the opposite side, and they should all intersect at the same point. All right, so let's find the centroid. In order to do that, we need to get the medians. So how do I find the midpoint of this line? Well, we can use the perpendicular bisector. It should bisect this line, and bisectors, by definition, will go through the midpoint of any line. So that's why I've said before, you need to be really good with just constructing perpendicular bisectors. Okay. And drawing my arcs. I've gone through this in other videos before, so I don't really feel the need to go through it. At this point, this should be really easy for you. So rather than drawing the actual full line, what I'm going to do is just mark the actual point where it would intersect this line right there, that point. And I'm going to connect it to the vertex of the opposite side. Now I have one of the medians, right there. I have to do it for the other two sides and connect those to actually find the point of concurrence, right? I can only have intersecting lines by having lines. Novel idea. All right, so a little less than half is what I'll go with so I don't end up with huge arcs there. And right there. Okay, and once again, I'm not going to draw the line, I just need this point, and I connect this midpoint to the vertex opposite it, right? The only vertex that it's not connected to already. There and there. That should be good. I think that was lined up slightly off, so hopefully that doesn't mess up our point of concurrence too much. So I already know that the last line should go through here, right about this point. But I'm still going to draw the final side. You are probably going to be required to on an exam. And then I'm going to talk about some basic properties of centroids. Right, I've seen them come up in, like, the properties of medians come up in word problems before. Okay, I didn't make this arc long enough. Not nearly. So I have to go back. That was a bad noise. Okay. This point here. And this point here. I find that midpoint, and now I connect it to the other point, and now that I've connected all 3 points, my centroid should be exactly there. So for exam purposes, don't worry if you're a little bit off, if all three lines don't connect exactly. My compass is like, it depends on the quality of your compass sometimes. As long as your construction lines are correct, you should get full credit, right? I've used this for drafting and stuff like that in the past, so I kind of made sure to get a good quality one. But if you're just in a geometry class for like a year, you don't need to like buy some expensive compass, you know. So properties of medians that typically help is, and centroid really, is that the centroid splits up these medians into a 2-to-1 ratio, right? Meaning, see this line here? This line and this line have a 2-to-1 ratio. So this line is twice the length of this line. If this line was 3, this line would be 6. If this line was, for example, 10 instead of 6, this line would then be 5. I've seen problems come up where they'll give you a picture and say, here's a bunch of medians, and then they'll say, okay, maybe this is x minus 4, and this is x plus 2, and this entire length is 24. What is the value of x? So knowing that ratio should help you determine what that is, okay? What x is and stuff like that. I won't, this video is just on construction, so I won't go in depth into that anymore. All right, so the next example we're gonna go through, the next point of concurrence, is an Orthocenter. Now I'm gonna do 2 examples of an Orthocenter because this one's a bit weird. So an Orthocenter is the intersection of all altitudes, which means it's going to be a point that goes down from the vertex of the triangle, so it is perpendicular to the opposite side, okay? Depending on whether you have an acute triangle, an obtuse triangle, or a right triangle, your Orthocenter might be on your triangle, inside your triangle, or outside of your triangle. So I'm going to do an obtuse and an acute triangle just to show you the difference between like what they would look like, right? It's not weird if you end up with a point way outside for whatever reason. It depends on the type of triangle you're working with. So let's figure out how to make an altitude. An altitude is essentially a perpendicular line through the vertex. It's the exact same construction as a perpendicular line through a point. So that's what we're going to do. Here's the point. Just imagine these 2 lines aren't there. And this is a construction you should already be familiar with if you're learning about points of concurrence. So I create an arc like that. And see, it doesn't totally intersect this line. That means I'm going to have to extend this line in order to be able to do this construction. So let's just extend that line out that way. And now I have this as my point of intersection, and this is my point of intersection with the arc. I need a perpendicular line. So what I'm going to do is I really only need an arc on the bottom, so for just the sake of not having a bunch of arcs, I'll do it that way. Now I have this intersection point here. I connect it through my vertex like that, okay? So that is, I'm so slightly off with that, but shouldn't matter that much at the end of it. That is in altitude. We're gonna now make the altitudes for the other 2 sides. All right, so we need a perpendicular line through a point. I'll go with this one, and then I'll do this one. Okay, so here we go. First, place the point right there. I'm gonna draw an arc, connect. Oop, I'll need to extend that line also. Here and here. Let's create the arcs. So like I said before, I only need the arcs down below because to create a line, you only need 2 points in Euclidean geometry to actually form a line. So this is one of the points, and that's my other point. Having the arc continue there, although wouldn't be incorrect, is, I think, going to make the drawing a lot messier. All right, so going through there. I know I'm slightly off with this, so my construction here, my line here, is not going to exactly go through this point, but it should be around here. Okay. Again, for a test, this is fine. If you're doing some sort of design where this needs to be somewhat accurate, erase and redo it. Not that big a deal. Okay, so just got to make sure that's a little more than half. Yep, goes past. And see if I can make an arc. Yep, right there. Okay. So now I just... one arc there. And one arc there. Connecting those 2 points. See, it's slightly off. I'm not sure if you can totally see right there. It's just a little bit below where it needs to be. Or I suppose since this is correct, this is a little bit to the left of where it needs to be. But yeah, so that is the orthocenter. And this is an example of what would happen in an acute triangle. It would show up inside. Now let's show what happens when we find the orthocenter of an obtuse triangle. So, same steps as before, perpendicular lines through a point. Okay? Here we go. So, here's one. I'll do the easy one. I'll start on the obtuse angle. Yep. And just a little more than a little past, and I draw my arc right there. That's an easy thing to work with. There's one arc, there's a second arc, and yeah, this is the perpendicular line through a point construction. Again, at this point, I'm not going to go through slowly explaining it. It's one you should have down by this point. Okay, just lining that up. And for this line, you want to make sure to extend on both sides. Because right now, we're not sure where the intersection point's going to be. Because watch what happens with the other sides. The actual altitude is not going to end up inside. So I'm going to go a little more than half and try to intersect. So that's one point of intersection. And we're going to need to extend this line out to get the other. Here's what we do. We draw that out. So here we have 2 intersections, and we're going to do our perpendicular bisector thing. Okay, so here's going to be one arc, and here is the other. Now, if you notice, our altitude is completely outside our triangle. In an obtuse triangle, there's no way to draw a line down where that's 90 degrees. I think that can be kind of plainly seen. Okay, so there's our other altitude. See how the altitude's going to end up somewhere here? And I'll show you. I'll do the altitude for the third side, and you'll see it's going to end up way far outside of the original triangle. Okay, so same thing. I'm going to actually start by just extending this line. Right, I'm going to begin with the line extension, just to see if it ends up making it easier to deal with smaller arcs, because that was a lot, of a larger swoop than I kind of prefer dealing with. And yep, it did. Okay, and here are my 2 endpoints. And again, this is construction of a perpendicular line through points. Let's draw this out there and draw this out here and connect through that point. and we see the point of intersection right there. That would be the orthocenter. All right, so next we're going to see the circumcenter of a circle. Now that point of concurrence is the intersection of all the perpendicular bisectors of each side of the triangle. With this, we'll also be able to do something called circumscribing a circle around a triangle. That would mean we're going to be able to draw a circle such that all three of these points exist on the edge of the circle. And that's going to be done using and there won't be two separate explanations. First, I'll find the circumcenter, and then right after, I'll use the same triangle to circumscribe. So let's just go through getting a circumcenter. Intersection of all the perpendicular bisectors of each side. So let's just do that. Perpendicular bisector of each side. Simple enough. So here's one. There. And there. So I'll just draw two arcs down this way, and I won't finish it just because this is going to be pretty messy, and I'm fairly certain they'll intersect up there. Right? There's one point, and there's the second point. Now I'm going to just make sure I draw it long enough through that point. The thing with that's important to note with the perpendicular bisectors in the circumcenter, you could end up with a circumcenter that is outside your triangle. That will happen with obtuse triangles. Acute triangles, they will have their circumcenter inside the triangle. However, unlike doing altitudes and doing the orthocenter, it doesn't affect really how the circumcenter looks that much or anything, or the method of circumscribing a triangle. I just wanted to do two examples with orthocenter because it does look weird. Okay, but back to circumcenter. I hope I didn't mix up I'm doing the perpendicular bisectors with the other two sides. I hope I didn't mix up saying orthocenter and circumcenter a bunch in that last little ramble. Okay, so that's a little more than half. And wow, okay. And I draw straight through. This is actually close to a 90-degree triangle. So, and there's a whole reason for why this would happen, but a 90-degree triangle, the circumcenter would be on the side, on one of the sides of the triangle. Specifically, the side opposite the right angle. Okay, so it looks like that is going to be our orthocenter, and if we do the perpendicular bisector of this, should actually cross that point. So let's just double check. All right, and that's definitely not half, so a little more than half. Do our arcs here. All right, that looks long enough. Do an arc here, here. Oof. I'm gonna just extend that other arc just for. Ooh, that was a good noise. Okay. Now I'll extend a line through there. Just one here. Okay. Okay, so that's going to be our circumcenter. Now, how do you circumscribe the circle? We're going to use the circumcenter. Oh my God, I'm saying this so much. It's not even sounding like words at this point. All right, so how do we do that circle thing? Circumscribe. Take the point of your compass, put it right on the circumcenter, take the pencil lead, and then just put it on any of the three vertexes that you currently have for your triangle. And now draw a circle. And see how one of my points is slightly off? Again, that's fine for a testing standpoint. One of my perpendicular bisectors was angled slightly incorrectly. So I end up with this. Now you might have to run that back a few times just to really get it. There's a lot involved in these points of concurrence constructions. But we only have one more to go, so that's good. There's really only 4 of these. All right, so the last point of concurrence we're doing is the incenter. The incenter is the point of concurrence, or the point of intersection, between all angle bisectors in the triangle. Then we're going to use the incenter to inscribe a circle. So that's going to be drawing a circle inside the triangle such that the circle touches all three sides of the triangle but doesn't cross it, right? All three sides will be tangent to the circle, meaning it only hits it at one point. At this point, I'm actually not sure if you would have learned properly what a tangent is. Some classes might actually go through constructions first. Some might save it towards the end. However, talking about tangents, that's in a circle unit, which might be towards the end of geometry. They go through circles afterward. All right, so we need to do 3 angle bisectors to find the incenter. All right, you're going to see eraser marks because my compass moved a bit and it would have made really inaccurate construction, so I'm going to start over. Yes, even a professional mathematician and scientist messes up using a compass. So let's go through this. Angle bisectors, right? We should already be familiar with that construction. Make an arc here, make an arc here, and here. What's nice about angle bisectors and about actually circumcenters, not circumcenters, sorry, centroids, is that they're always inside the triangle and never confusing. I think, however, this has an incenter associated with it, so it's not as nice as just doing a straight up centroid. Okay, cool. So that's one angle bisector. And we just line that up. Okay. There's a second angle bisector. Or there was about to be. Yeah, I messed up. Okay, make sure your ruler is steady when you draw a line. Okay, and now we just have one more angle bisector to do. Again, this is slightly off, but not a big deal. Now, once you have 3 angle bisectors, that's going to be your point of concurrence. And then you would have found your incenter. Now, the incenter helps you inscribe a circle, and I'll show you what to do at that point. Okay, I'm pretty sure this one was off, so I'll just slightly adjust there. So that's going to be my incenter at that point. Now, inscribing a circle means this is going to be the center of my circle, so put the point of your compass there. And just make it so your compass, and just do this by kind of running side to side. Make sure it just hits one of the sides, right? Just keep extending it until it just hits the side, like it grazes it. Okay, and from there, yeah, that's good. Draw a circle, and it should just about hit all 3 sides, like that. And there, you would have inscribed a circle and a triangle. And that's the final construction for concurrences, and that's pretty much it. All right, so this was one of the trickier parts of constructions. Points of concurrence can get very annoying, but really it's going to be about practice. Just practice them over until you remember the steps. If you have any questions, just leave something down in the comments. Hopefully this helps.